Welcome to the section. Now I am going to explain the electrochemical series that is very helpful. One of the application we can say in the electrochemistry. So what is the electrochemical series? See, when I explain the hydrogen electrode, it is called as a primary reference electrode because we arbitrarily fix it as potential is 0, and based on that we couple this hydrogen electrode with any other elements, that is metal ion electrode, and we can find the potential. So that is the objective and the requirement need for the reference electrode. So by the way, we can measure whatever the elements in the periodical table, we can measure the potential of the specific metal or element electrode by couple it with the hydrogen electrode. So the hydrogen electrode potential of all the electrochemical series. So electrochemical series means we can any electrode. We can create any electrode by made up of elements that present in the periodical table. So whatever the component that elements, how many elements in the periodical table, that number of elements electrodes we can create. But what is the use? We know the cell. If you know the cell potential or electrode potential, then only it is very helpful for any studies. So for that one, we create an element electrode and it is coupled with the hydrogen electrode, and the electrode potential is measured. That electrode potential is placed in a increasing order in a table that is called electrochemical series. So by coupling a hydrogen electrode of all the elements in the periodical table is measured and arranged in the increasing order of their standard reduction potential. So here I am giving you one example table, that is where metal series and its potential and is all the potential reduction potential. So we place the highest negative in the top and the more positive is a down one. So I am writing only 12 elements which most probably we are using in many example. So if we have 108 elements in the periodical table, we can create 109 number of electrodes here, and that will be available in the Jain and Jain engineering chemistry book. And I can able to write only 12 only here. So I write important metals and its potential, reduction potential. Then what is the importance by having this potential? What are the idea we can get from this table? That we have to discuss now. So by placing the highest negative in the top, by highest positive in the bottom, and center is hydrogen, which is whose potential is 0. So we can understand that which one has the highest negative potential, that is reduction potential. It is good for oxidation process, or the top good metal, it can act as a good reducing agent because by doing easy way of oxidation. While you take an example, magnesium, which is minus 2.37 reduction potential, that shows that its reduction potential is highly negative, means it is favor for oxidation and it can act as a good reducing agent. And while you have a gold at the bottom which has a more positive, that shows that more positive reduction potential is favor for reduction and it can act as a easy oxidizing agent. Bottom is a good one for oxidation, oxidizing reagent by easy way of reduction. So we can understand that which metal have a good reducing agent, which metal is a good oxidizing agent. If a reduction potential is more, it is a reduction potential highly negative, it good for oxidation and act as a reducing agent. And while that is the third application is when you couple with the two electrodes. For example, in the Daniel cell we are coupling zinc and copper. Zinc has a minus 0.763 reduction potential and copper is a plus 0.337 reduction potential. That shows that the negative value of zinc shows that its favor for oxidation. So when you couple the zinc and copper, we can understand that zinc always acts as an anode because its negative potential, reduction potential, makes this one as anode. This positive reduction potential makes this cathode. So this is the main applications of electrochemical series. So what is electrochemical series? A serial arrangements of all the metal ions reduction potential is called electrochemical series. So here I am writing the reduction potential. So this is called electrochemical series specifically for reduction. And the same way the electrochemical series for oxidation is also available. Most probably we are using reduction potential table only. So what is the thing in the oxidation series? The same thing is there, but in the symbol is opposite, because here it is a reduction potential is negative, no, so that shows that it's favor for oxidation. Its favor for oxidation means in oxidation table it present in the positive sign. That is only the difference between the reduction potential series, oxidation potential series. So that idea is enough. So what is the information we can get? If you have a reduction potential is negative, it is good for oxidation. That is the first point. Next, if you have a more positive reduction value, it is good for reduction. So when you couple any metal, for example you couple aluminium with your mercury, so when you couple aluminium with mercury, aluminium always act as a anode because it have a negative reduction potential. If you then mercury which has a positive, it act as a cathode. So if you couple aluminium and mercury, they shows that anode and a cathode. So by even when you couple with the copper and mercury, so for example I am coupling copper with mercury, okay, so whose reduction potential is low, that act as an anode. So its reduction potential is low compared to mercury, so it act as an anode, mercury act as a cathode. So this is what the information we can get from the electrochemical series. So first one is which the mode of reagent capacity, that is whether it act as a reducing agent or oxidizing agent, that we can get from the electrochemical series. Second one, where by coupling two different metals, metal ion electrode, which one act as a anode, which one act as a cathode. So that information, by without doing experimental, by theoretically we can find which one act as anode, which one act as a cathode. This is what the application of electrochemical series. So electrochemical series, the important two application we discussed, and the last part of the electrochemistry is still now we discussed many electrodes, cells, cell potential and cell reaction. Everything is all electrochemical reaction. There is one more thing is that electrolytic reaction. So now we have to understand what is electrochemical reaction, what is electrolytic reaction. So electrolytic cell, when you get when you have two different types of battery, like everyday battery and lead acid battery, you can take everyday battery you are using and you are getting current. After that it will not, you can't recharge the battery. But lead acid battery you are getting current, after drain of your electricity electric power you can charge it one. So we understand that the everyday battery is a use and throw battery, only you can get electric power from the battery only. But in the lead acid battery you can take electron and you can also pass electron into the battery, and you can cycle of experiment, cycle of energy drain, energy gain is possible. That is, reversibility is there in the lead acid battery. But everyday battery only the one way, that is electrochemical, there is some chemical reaction is happening and some doing the some chemical reaction we are getting electric power. So this is what the difference between the electrochemical cell and the electrolytic cell. So lead acid battery can act as a both electrolytic cell and electrochemical cell, and everyday battery only act as a electrochemical cell, not electrolytic cell. So difference between electrochemical cell and electrolytic cell. So electrolytic means what? See, when you have a battery is there, you are getting energy, electron is flow from the battery to external. So this is called electrochemical. Okay, if you have a battery, so this is one battery and you are supplying electric power from external to within the battery. The electron is passed from external to inside of your battery. Then it is called electrolytic. electrolytic. Okay, so this is what the difference between the electrochemical and electrolytic. So here electrolytic, electrical energy from the external is passed into the cell, that makes doing some chemical reaction, and it is stored within the cell, that is called electrolytic cell. Electrochemical cell means what? Here doing chemical reaction we are having electron, so electron is from battery to external, then it is called electrochemical cell. Then here the charge, negative charge of carried by the cathode, because the cathode only the source which is from the external is passed into the battery, and here the electrochemical cell, the negative charge is carried by anode. The same thing for cathode and here vice versa. And when you think about the electrolytic cell, the Faraday law is used to estimate or find out the theory within the cell. But in the electrochemical cell, only the concentration of the electrodes, electrolytes, and the type of electrode makes an important role that explains the mechanism that happen in the electrochemical cell. And to estimate, coulometer is used for electrolytic cell, and potentiometer is used for electrochemical cell. So it is only for external energy, it is electron drawn from the cell. So electron, where is electron drawn? So in electrolytic cell, external electron is passed into the battery, and in electrochemical cell, the electrons from the cell is passed into the external source. So this is what the difference between electrochemical cell and the electrolytic cell. So up to now I explained what is the application of EMF series, how we can understand when you couple the two electrodes, which one act as an anode and which one act as a cathode. So there's some more applications of electrochemical series we have discussed, and the difference between the electrochemical cell and electrolytic cell we discussed in the today lecture. Thank you for your patience. Thank you.